All right, so let's start it up. Let's fire up the coffee session. This is Engineering Labs recap, take 2, or with team 3. We had some very original names. I know we didn't spend much time naming ourselves in this. It was just team 1, team 2, team 3, team 4, and team 3 is the second team that made it out alive. They were able to come out the other side of the engineering labs with something to show for it. So we're sitting down today talking to them about what exactly they did and how the process was for them. The first thing that we should probably do is figure out who is team 3. Who are you all and what are your backgrounds? So Laszlo, you are first on my screen. I'd love it if you give us a little bit of info about yourself for those 5 people that aren't already in the community Slack and haven't seen you on a thread. Feel free to tell us, who are you, man?
Hi, so my background is in finance. I used to be a quant researcher. I worked on the company that makes Candy Crush, so King Digital, as a data scientist. And the last 4 years, I was head of data science at a London startup that works with investment banks in market intelligence research, so news processing, NLP. And the last year, I run my own consulting company, which specializes in machine learning product management, which is the management side of the machine learning process.
Perfect. Sweet, man. The claim to fame is the Candy Crush. So we've got Artem on the next screen. Who are you, man? Give us a little information and background about yourself.
Yeah, hi all. My name is Artum. The Y letter is from my surname. I'm an MLOps engineer in company Neuro, and actually my MLOps experience started when around those days when the MLOps community was commenced. Before that, I was just a software engineer working on the ML platform, which I think many of us were in the past. So I knew before the labs, I knew what the MLFlow and what Pytorch are. I didn't have like hands-on experience, so I kind of had some big view picture on how it's supposed to be used, and yeah, so I was curious about everything about machine learning, about development, and about infrastructure and everything. So it appeared to be that the most interesting part for me, like the part that no one took, was the infrastructure. So during these labs, I learned Kubernetes, and it was awesome, and I loved this experience. So
nice.
Yeah, that's it.
Well, this is probably a good moment to mention, in case there's someone that is listening that hasn't been following along with this whole Engineering Labs initiative. What we did is we threw these guys off the deep end. We told them, go out and swim, learn how to swim. There's sharks in the water. There is no safety net. You get to choose your own adventure. The only constraints that they had were that they have to use a combination of MLFlow and Pytorch, right? So those were the 2 things that they had to do, but everything else was open. Everything else, they could choose what they wanted to do. So if you looked at the last group, Engineering Labs, number 1, team 1, they chose NLP models. And soon we'll figure out what these guys chose. But first, let's get a little introduction from Dimi, who shares my same name. We are brothers of different mothers. Dimi, sure. aka Demetrius.
Exactly, but with an I instead of an E. But yep. Yeah, so I'm Demetrius, shortcut. I just go by Dimi. I'm from Greece. I live in Germany. My background is mathematics. I work at KPMG mostly on data science and BI related topics, where we just bring data science and machine learning into production. So focus is on operationalization of machine learning and data science and architecture in general. And how do I come here? Well, even though we are working mostly with major cloud providers for that past half year, I've been doing some research into workflow and technology stack options to facilitate the whole process. So I came across some of your YouTube videos, so coffee sessions, and then I joined the Slack. And yeah, this
Never looked back.
how I ended up here.
Yep. Wait, so you said you are working mainly with major cloud providers. Does that mean that you're using solely their tools?
Yeah, mostly. I usually work with SAP, Azure, AWS, and things like that. Whatever clients are using, but yeah.
And so it's like fully their tools, everything. So you're not getting to go and shop around and see what the best in breed is. You just
we do.
Oh, you do?
We do. Yeah, but this is
Okay.
why I kind of started looking into those open source world options as well to facilitate the whole process, basically.
Okay, cool. So the last on the list, last but not least, we've got Paulo. Fala, Paulo. What's happening, man?
Hey guys. So my name is Paulo. I'm a data scientist at Nilgai, a consulting company here in Porto, Portugal, that is now worldwide due to the pandemic. And I graduated in biomedical engineering in the Faculty of Engineering of Porto, like 1.5 years ago in July 2019. And then I started working in consulting, but I've been focusing mostly on the data science part, so training machine learning. But lately, some of our projects have had a component where I need to actually help the client deploy them and make it work in production. So I started learning some more things about MLOps. And I found a community by a co-worker which participated in the engineering labs, but didn't finish. I don't know why. She was part of one of the other teams. And well, when she mentioned that this was going to happen, I immediately joined because I wanted to learn some more things about MLOps and specifically MLFlow and Pytorch, since I mostly focused on Keras and TensorFlow in the past.
Oh, nice. Okay. So for a little bit of a roundup here, we've got Dimi, who's working pretty heavily in the MLOps section. Artum's coming, or Artum, sorry, I keep pronouncing the Y because it says it right there on the screen. But Artum's coming from software engineering background. I think a lot of people can relate to that, and then getting into the ML section. Laszlo's just a jack of all trades, and everyone who is in the community knows that. But Paulo, you were coming from this heavily machine learning background and then making the jump to the ops, kind of just saying, okay, I need to operationalize this. I'd love to hear just the basic of what you guys decided on. And maybe Paulo, you can give us, what was it that you said, and later we'll get into the process, because I saw you have an awesome process. I watched the Slack channel as you developed how you decided what you wanted to work on. But can you just give us an idea of what you came out with?
Okay, so our initial idea actually went a bit down the water. We spent a lot of time planning and choosing a data set, and then we ended up choosing a slightly different data set due to the content of the first one. But in the end, I think we came up with a decent product. So it was also an NLP approach. We use a data set that is typically used for benchmarks. That is the YELP polarity review data set, where you have an associated score from 0 to 5 or 1 to 5, I'm not sure, for restaurant reviews. And what we did was try to classify the review score, whether it was positive, meaning larger or equal than 3 stars, or negative. And our model was then deployed using a dashboard created on Streamlight, where the user can just input a review. The model uses that text for doing a prediction. And then what we display to the user is whether the model agrees with what the user thinks the review is. So the user can input, I think my review is positive, or I think my review is negative. And we just save the stats regarding that interaction. And for the backend part, Artem is a lot more specialized to talk about what's making it run.
Yeah, let's hear that.
Yeah, so about the backend side, the Streamlit was the facade of this whole, let's say, system. Dimi, thanks a lot. I know it takes just 50 lines of code, but it's like pure engineering to make a cool web UI in just a few lines. Yeah, so this basically, I think, like having this facade at the very beginning meant that we had the direction of what we want to achieve, and after this, we were starting to expand the backend. So at the backend, there are a few components which were the model serving. It's just a REST API. Unfortunately, we couldn't make MLFlow's model serving work, and for some reason we didn't even try to make TouchServe work. So we just thought, it's just a tiny microservice. I can write it down. So we implemented it with hands. Yeah, the idea to provide the feedback for the model and store it somewhere to get the statistics of the predictions was a kind of implemented in the model proxy server. It's like the kind of the proxy that looks outside of the world and like collects this information, talking to the model through REST API inside the cluster. And also we implemented a small service that we call it model operator. It's the service that synchronizes the state of MLFlow and the model that is actually deployed. So it's kind of, I'm thinking about it as of GitOps for MLFlow. I'm not sure, like, I was surprised that there was nothing on the market, nothing on GitHub like this. Maybe it's like a bad practice. So it's interesting to talk about it. But the idea was that you have this model registry in MLFlow. You have all the metrics, all the models listed. And you can say that, like, okay, I deploy this model. I want this model to be deployed instead of the other one. And you just put the tag, like this, change the production tag for the model. And the synchronizer, this model operator microservice, that it constantly polls the state of MLFlow server, mm-hmm. And once it sees that the model has changed, it automatically redeploys in Kubernetes cluster the model. So
why do you think that could be a bad practice? And for those who want to play around with it, it is on GitHub now, right? We have that yes. on our GitHub, yes. which we'll link below. So now, if that ever happens again and there is an Artem that is looking for it, your future self, you can go and check this out. But do you feel like that is bad practice? I don't see why that would be. Maybe somebody else has an idea of why that would be, but it feels like that's perfect for the job.
Yeah, like so like let me answer this quickly. For the demo, it works perfectly. It's like very visual and very interactive. But for the real use case, I would not say that having model registry being the central component that triggers the other pipelines is like the best idea. What the other team did, having the Git registry at the center, and which triggers the, I don't know, data pipelines, model pipelines. Maybe it's kind of more reasonable because we work with code. We don't work with models.
Yeah, that makes sense. So it's in the wrong place. The trigger's in the wrong place kind of thing. So you mentioned beforehand that Dimi did all of the engineering work on Streamlet, and it was the 50 lines of code that were hard to do. Can you walk us through that a little bit, Dimi?
Yes, of course. So it wasn't hard to do. It's literally, when I was looking through the tasks that we had on the GitHub repo, there was kind of a baseline or something already from Artem, and Paulo did a lot of work there too. And I saw that the whole front end wasn't developed yet. So from a workflow point of view, I literally knew Artem is going to eventually provide some kind of, he's going to deploy the model somehow, and he's going to provide me with some kind of API, which is basically then enables a decoupled architecture. So so the separation of front end and back end is easier. And this way, you know, you get all these benefits of allowing multiple users to use the same API and at the same time without interferences and stuff like that. But so I just literally just created a Streamlet with some, I usually don't really do front end stuff, but I just like Googled quick Streamlet and I wanted to try it out. So yeah, and just built up the application that just uses the input of the user, how Paulo described already, and then uses the API and returns the prediction. And around that, we built some kind of user experience where, as Paulo has mentioned as well, you can basically, as a user, write in your prediction if it's going to be positive or negative, the review, and it's going to return you kind of a statistics about that.
That's awesome. So now let's get into Laszlo's territory a little bit and the whole managerial side of things and the process. I'm really curious to know about the process of you all choosing one thing and then having to pivot and why that happened, how that happened, and the process of going through that. What was that like and how did you manage it?
Yeah, so usually these volunteer-based teams are, you know, from a management perspective, it's a bit different because clearly, you know, in a commercial setting, the manager has an authority over what's getting done and the ownership of the problem. And this was kind of missing here, but it was still useful because you know, my personal goal was to understand of how to motivate a team to move in a more MLOps way of doing machine learning. What kind of skills do you need? You know, how quickly you can pick it up, and what kind of problems do you have? So getting back to the point of selecting the problem, I think there was a list of candidate problems what we wanted to choose from, and you know, we are conversing on Slack about this, basically about plain, you know, the names of the problems. It's very hard to make a decision, and I think usually when you have a commercial problem, you have a much more insights into the problem. And I think we picked I think biased language or something in this topic, and I think we decided on it. And I downloaded the data set and started reading it, and then it was like 4-letter words, you know, in every line. And I said, I'm not going to read 4-letter words, you know, a couple of weeks from now on. And then I raised to the other guys on the Slack channel to, you know, guys, maybe we should pick another one because we don't want to, you know, work on something which we feel uncomfortable with, even if our intentions are good. And then we picked this YELP data set. And I think we selected it partly because it's an NLP problem, and it is large enough that the amount of data what we dealt with is not trivial. So it means that this warrant this level of you know, engineering and infrastructure. You can't just solve this problem in scikit-learn and get on with it.
Perfect. Great insights there. I mean, it's such a different mode of acting when you're doing this all on your volunteer time or your free time, right? There is a lot to be said about this. I mean, you all had a lot of drive and determination to get this done. And so I kind of got a sense of what everyone was looking to get out of this. I mean, it seems like, Laszlo, you said it nicely about, okay, I want to see how the process looks, how you can enable teams to act in a MLOps way, and how long does it take to get people up to speed? How long does it take to actually do something? Then for Artem, I saw it's like you wanted to figure out a little bit of this backend. Is that what I am understanding from you? You wanted to get more of that and play around. Dimi, I'm not so sure. What were your biggest things that you wanted to take out of this?
I had played previously with MLFlow already around, and I knew what it's good for and what's not. So I kind of wanted to see how or which path we're going to take architecture-wise, from an architecture-wise perspective. And I still remember how Artem and I were just collaborating upon that. And I tried to explain how, we could do this very MLFlow centric, or just use MLFlow just for tracking and maybe registering the model, but not more. But then we did the whole MLFlow centric way with, and put on top all the fancy Kubernetes things from Artem, and made our lives very complicated. But
Yeah.
that was kind of my motivation here, to see, especially if we had a little bit more time, what we would build on top of that, and for example, to monitor things, or things like that.
Yeah, that's actually a really good point. What would you have built on top? Like, to monitor, would you have slapped on some Prometheus and Grafana, or what were your thoughts on it, on how to flesh this out? Because this is really like not the whole piece of the puzzle, right? This is just this is a small piece of the puzzle, I should say. And it doesn't get you all the way there. However, it does get you a nice start. So what are some other, and anyone can jump in too, but Dimi, maybe you can start and let us know what else did you want to throw on top of this?
I mean, first, that was also with Artem. I tried to, because MLFlow is trying to be, the kitchen sink kind of an end-to-end solution. So I was like, all right, let's try to monitor or whatever the incoming data that comes from the user, right? So like it would come in, and then you would somehow track the distribution or whatever it is from the users. And then I realized that with MLFlow, the tracking that you use there, the backend works on any SQL alchemy, and I think the front artifact store on whatever object storage you want. But I realized that when you try to use some real-time results or give them back to the user, the way it gets the data out, it's very manual. So it goes like, even though the metrics are saved in a database, in the end of the day, they get it goes through it by rows, just programmatically by Python or R or whatever you use, which I didn't like in the end, but I was just trying it out. So yeah, that's from my side. Of course, I would add other monitor tools on top, but since we didn't implement any retraining or anything like that yet, there wasn't really any reason, let's say, to build things like that yet.
Well, that is a great point. And the retraining, I guess, would be another step in the future, right? What are some other things? Maybe, Paulo, you have an idea of where this would have gone if you stuck at it for another 6 weeks or 8 weeks?
Yeah, we could do some of the retraining with the user feedback we got. So since we're storing the predictions the user thinks are correct and the actual model predictions, we can just have a feedback loop for redeploying the model and checking at which point the predictions are getting a lot worse. But the user can also play around a lot with this, since the feedback is explicit, and people can just do multiple answers with the way we have things now. We could make this a bit more robust And I think it will also be interesting to add some explainability tools. So the model we use is quite simple, but we can have more complex models that tell the user why the model thinks their prediction is positive or negative.
Yeah, that's a huge one. And it is super important to let people in on all the fun and let them know why. I see Laszlo looks like he has another thing that he wants to say about where you would take this next.
I'm not sure whether purely for the sake of it we should add more components to this. I think the most important thing what we do is we already do is to save the input-output responses and the model version into a separate database. And in a like, let's say, a startup setting, when you have limited amount of resources, that would be the main source for analyzing the performance, because this is a relatively low churn model. So it means that unless you have like really millions of users, you're not going to collect enough data to retrain the model purely on the basis of the user data. So this is always important to keep in mind. It's every component what you add in an MLOps system has a maintenance cost and an infrastructure cost and an implementation cost, and these adds up, But obviously this is a lab, but in a real setting, these need to be taken care of.
Well, I like that insight. I like the wisdom of that. Like, don't just add bells and whistles because you think it's going to make it better. Like, really ask yourself if you need these bells and whistles and if they truly are going to add as much value as the hassle that they're going to be. So let's talk a little bit about what you all didn't like and some things that, let's start with, so we know, I'll set the ground or I'll set the scene right now that we gave you not a lot of direction, and that was probably our bad. Well, not probably, that was our bad. We could have given you a lot more direction, and we're going to improve that for the next labs. We're going to give much more direction and hopefully have better guardrails set in place so that it's not so broad and you don't spend so much time trying to figure out just step one. But apart from that, let's talk about using MLFlow and Pytorch. I mean, this is something that I know Yvonne was really excited for because it just came out. We wanted to see how it actually works and how it is in the wild. I mean, Dimi, you said that you've been using MLFlow before. You also mentioned that it is taking this approach of the kitchen sink, like throwing everything. Oh yeah, metric tracking, we do that really well. But you wanna serve the model? We could do that too. You wanna monitor it? Yeah, we got that. Don't worry. Anything you ask us, it'll be there in the next release. So I can understand that probably leads to being a jack of all trades, master of none kind of thing. And I'd love to hear, maybe Artem, you want to start us off on what was difficult with this process? And it doesn't have to be on the MLFlow side, because I know that you were doing a lot of backend. So just in Kubernetes, was there things that you were having trouble with? Because I know that's also not the easiest.
Yeah. So we're not talking about the like self-organization and project management, or should I include it here?
Let's
hold off on that one.
All right. So like not talking about this, I would say that the most difficult part, which we I unfortunately could not implement at the end, was the taking all the advantage of tracking models of MLFlow, because how it looked like, because of some difficulties that the servers where we were training the model didn't have access to the other internet, so we couldn't access the MLFlow server. So we started to do something. So with all these difficulties, the problem was that we first implemented the model, then we froze the environment, froze the code version, froze the, let's say, metrics, everything, and then just put it to MLFlow for the demo purposes. So I would love to see how it like brings the value, you see.
So
Yeah.
basically you weren't able to take advantage fully of MLFlow because of that?
I think Paulo is more right person to answer this because he was considering and developing the model. But from my perspective, this was kind of like secondary, and this was probably the mistake of, where we started to implement where we started to engineer all this.
All right, talk us through that, Paulo. What happened?
Yeah, for MLFlow, we were learning as we went developing. So our initial iteration was a very complex model, an LSTM model. And this just used some tutorials I found on the internet, which had like a custom data loader for that already did some of the NLP tasks like tokenization and saving the vocabulary, etc., which is the hardest part of doing NLP in Pytorch. And I spent a lot of time developing that model, but I didn't integrate it right away with MLFlow. And at the end, when we're trying to log the artifacts, we noticed that the model couldn't be pickled in MLFlow, probably because of that custom data loader. But the error really wasn't easy to solve. So we just swapped the model to use a simpler one, and change the data source to use the built-in dataset in Torch text instead of using a JSON file, which is a less realistic input as it's already pre-processed in the correct way.
Interesting. All right, now talk me through some more stuff that wasn't the most ideal. I'm trying to remember what Team 1 was saying they were having problems with, but I can't right now. Maybe in a minute it'll come to me. But Dimi, how were things with you? What did you have to say? Did it change your mind working on this when what you thought about MLFlow, I should say? Did your mind get changed?
No, it didn't. So I still have kind of the same opinion about MLFlow. I agree with Artem. It would have been nicer to have at least a tracking URI for developers hosted somewhere right away, like on Azure or something. So we could all use that right away and see kind of the benefit of the tracking. But the tracking itself, being MLFlow and having this Pytorch integration now all new, was also a little bit tricky because I remember I did a little baseline with just auto logging a model. I think a scikit-learn model or whatever. I forgot what. No, it was actually Pytorch or something.
Yeah, it was an MNIST dataset.
Or MNIST, yeah, with the MNIST dataset. And of course it works, but then just using Pytorch, it came with some limitations that Paulo can tell. I think you couldn't use everything you want, right?
No,
it would only
the first issue I had
would only work for specific.
Yeah. The first issue I had was with the MLFlow version, because autologging only came recently, and initially I had an older version installed, so I couldn't even run your code. But then when I fixed that, I had the other pickle issue.
Yeah.
That was something that actually, now that you say that, Team 1 was also talking about the dependencies. And I think they had a problem with Python, the versions of Python that they were using, maybe, or not. I can't remember exactly what it was that they were having trouble with, but I remember it was dependencies. And yeah, it was. Yeah. So I can understand that is a tricky one. And I've heard people talk about that in meetups too, especially when you get, I mean, right now we're just working with MLFlow, right? But when you start to add a few different tools on top of that, the managing dependencies part really becomes half the battle. And so how do you make sure that you can manage all of these? Has anybody, this is just like a little bit of a tangent, but does anyone have any good ways of doing that?
I can chime into this, but
Yeah.
because our company spent a lot of energy on getting this right, and I mean, one thing is that try to avoid using notebooks as much as possible, because you have this tendency of installing anything onto your notebook server and then train a model and then send it to production, and then who knows what's. So what we did is we run everything in a Python script, and we recreate the virtual environment from the Docker's, so from the repository's requirements.txt. And if it doesn't work, then you can fix it and rerun it. But you know that the next person who downloads it into a new machine and creates a new virtual environment, we're going to have the same virtual environment. And pinning down the versions is very important, because you do get so scikit-learn are not compatible over different versions, and you're just going to get errors which can trip unit tests. So this is very important. I think from the Slack channel, you know that I don't like notebooks, but that's my bottom line.
I would just add that I don't fully agree with the notebooks. I still don't think if they are great or not, if they're awful. But I would just add that yes, scripts and environments, and I think this is like really important to base both your training, like development environment and inference environment, from the same base image. Because like in my company, we often get into troubles, even if having the same Docker file, building on the same machine, on the same like configuration in one cluster in Azure. No, in AWS it works. In Azure it's segmentation fault, and who knows what happened down there. So yeah,
completely.
We could probably have used like a GitHub runner or something like that to make the process more replicable, like running a Docker image with all the dependencies.
Oh, that's an interesting one to think about too. So my next question is along the lines of other tools that you've used to do the same thing for those who have experience with it. How did this compare? And are you going to go out? I feel like Dimi's going to say hell no, but are you going to go out and be like, for your next project, hey, we should use MLFlow? Did this convince you to have a deeper look into it, or was it something that you were like, well, I'm glad I played around with that, so I know not to use it? And maybe Laszlo, you want to go first on that?
We didn't use any kind of framework before, and when we reached the point that we were already operational, there was no point switching out of it. So I kind of ignored everything like SageMaker and MLFlow, but I think going forward in the future, that's going to be inevitable that you are using one of these frameworks, because they are getting better over time. I think TensorBoard is getting better over time. So you are kind of like moving towards this direction. Otherwise, you are losing out on a lot of convenience features. So I kind of understand that sooner or later you need to pick one. And especially if someone works as a consultant, they don't really have choice. They need to work with what the client suggests. So that's on one side. The other side, I was reading Artem's code, and what I recognize is, like, for an average data scientist that creates models and does analysis, using Kubernetes is way too difficult. Like, you'd really need, and I think we had a conversation, Artem, about this, is that there is so much detail there and so much domain knowledge on understanding Kubernetes, is that it requires a lot of skills that you're either a almost DevOps guy or and you don't have time for machine learning or business analysis. Or it's very rarely used. So you need to spend most of your time on Stack Overflow and GitHub to figure out what's going on, because you use it once a month and then some trouble happens. And these are neither very good skill goals or career tracks or paths, what you would like to do if you are a machine learning engineer who writes, by the way, good quality code, good quality pipeline code and stuff like that. But this is too specific for that. That was my biggest takeaway from this project.
Yeah, that's huge. And that's a huge debate that we have, right, all the time, is how much Kubernetes, or should a data scientist or a machine learning engineer know Kubernetes? And it feels like it's a little bit split. There's two camps, but Laszlo, you make a great argument for that. And my follow-up question to that probably is for you, Artem, is how much Kubernetes should we know? Do you feel like now that you know it, are you going to be using it more often because it is so powerful and it is so useful? Do you see areas where you can incorporate that into your work or your day-to-day?
Yeah, that's the question that I was waiting for. First of all, I cannot say that I know Kubernetes. I think it's the same as C, C++. No one knows it, even Straustrup. So even the Google engineers, I'm sure, don't know like all the subtle things working in different clouds and all this. But yeah, like first of all, I love Kubernetes because it gives you so much output for almost free. So you just you apply some configuration and voila, you have the deployment. You apply some other configuration, you have the networking established. You have, and all this is static. All this you just watch it. So like moving from this to the data scientists and Kubernetes relationship, I think that like from my point of view, Kubernetes is the best thing that we as engineering society could achieve in this evolution of DevOps. I'm not talking about Ansible and other things. I don't want to offend anyone. Yeah, but like comparing to to many other and like both static configurationable, like both declarative systems and imperative systems, Kubernetes is the most utilizable, most useful. So I think, yes, I totally agree with Laszlo that that it's too complicated to even to engineers, not talking about the mathematicians and data scientists. But I think that all the tools, like the platforms, the true way to build the platforms that's supposed to be used by mathematicians is something like restricted Kubernetes. It's like the more simplified but still extensible configuration, so that you work with it with absolutely the same way. You apply it, you use the same instruments, you use the same, there is huge ecosystem of instruments around Kubernetes, all the package managers, some useful stuff. So it should be something like smaller, but still the same, I think.
Like a Kubernetes for dummies?
No, for data scientists. No offense.
You do have some alternative packages like Nomad, which I think are simpler, from HashiCorp.
Yeah, good point.
Or
Sorry.
K3S is for lightweight applications, I think.
I'll check it out. Thank you.
Now we know. So moving on to the other side. I mean, Dimi, I feel like I know your answer, but MLFlow, are you gonna go out there and use it, suggest it to your next clients?
I think it always depends, but I personally like it just for the tracking part, just because it kind of motivates data scientists kind of to track whatever they're doing. Sometimes, a lot of data science or machine learning frameworks, they also provide you this like auto log or whatever, so you see R squared or whatever you have automatically. But it kind of gets them into a routine of tracking things and gives them an opportunity to collaborate with their colleagues without, having Excel files or whatever. So it's a little bit easier, and I think it's a good tool, especially for smaller companies and with data scientists to start with. But of course, when it comes into real productionization, you might consider as an end-to-end tool something else.
Why?
Yeah, why? Artem saying why?
Oh, you mean for MLFlow as an end-to-end tool?
Yeah.
Oh, that's crazy. I personally haven't seen it yet, and I have seen clients using Databricks that is basically also built on top of MLFlow and Delta Lake and Spark. But then when it comes to deploying, for example, they use something else. So it's just MLFlow is still starting. So I don't know how it's going to be in like 1 or 2 years. But just for the current state, I personally wouldn't recommend it to a client to use as an end-to-end tool. Maybe it will develop towards that. And maybe Databricks is going to invest more into their MLFlow enterprise solution or whatever you want to call that. But just for the current status, I wouldn't.
That's great insight. Yeah, that is huge. And
I have another comment on this one. And yeah, so first of all, how much Kubernetes a data scientist need to know? I mean, it's important to not think about data scientists individually, because you rarely do something alone in a commercial setting. So it means that that I think that was the conclusion of the conversation what we had with Artem, is that it's so great because it means that you are going to be a core part of every machine learning team from now on. And I think that's very important to understand, that it maybe the skill set is needed to perform machine learning, but maybe not in the same person. So that's one thing. The other thing is deployment is usually an engineering subject. So it means that you don't really have a say in how a model will gonna go into production. And most of the startups have 5 times larger engineering teams than data science teams. So it means that they will gonna have plenty of engineers who know Kubernetes, DevOps guys who take care of that. So they spinning up some kind of API, putting a model in production. That's a native for them. So it means that they're not going to ask your opinion of how do you want to have your model in production.
Interesting. And it triggers another question that I had around how much machine learning should the DevOps guys know, right? Not basically that whole question, but flipped on its head. How much Kubernetes should a data scientist know, or how much machine learning should the DevOps guys know? If anyone
how much
has
pickle the DevOps should know.
What was that?
How much of pickle subtle things should you know? Pickle and all this Pytorch packaging.
And that's it.
I can chime in on this one because I think machine learning is like a cultural movement, or it's like zeitgeist. So it means that everyone has it on its head. So you should be interested in from a cultural perspective. So this is going to be the biggest movement in like the next 20 years. It's the same as like internet computers in the last 20 years. So yeah, you should know about it. But professionally, I don't think so. I mean, it's too detailed, too abstract for someone who is not doing it professionally, getting involved in what's the difference between a transformer model and an LSTM. Does it really matters for an engineer? I don't, apart from obviously an intellectual curiosity.
But here's the problem that's currently on the market in LinkedIn. If you try to search for MLOps, you will find just 1 or 2 or something, at least in Europe, and everything is either data scientist, like Pytorch models and all this mathematics and rocket science, or it's machine learning engineer who makes everything from developing like rather simple models and collecting data and deployment and everything. So it's like, is it full stack or something?
Yeah, and we talk a lot about how the full stack data scientist doesn't actually exist, and that is a unicorn that only comes up in 5-year-olds' dreams. So I find that funny, like the idea that you're going to have someone do all of this. The more that I learn about MLOps personally, the more I realize, wow, this is a full team. It's really hard to find one person who's going to be able to take ownership of each piece of this and then do it well, right? Because maybe somebody will take ownership, but they're gonna make everything go to hell, and then you really have a pickle on your hands. So, Paulo, did you want to say something? I see you.
I think we should be able to. So we should know at least a tiny bit, just to get to a point where we can speak with more experienced people and understand part of what they're trying to say. We don't need to understand how to implement Kubernetes server from scratch, but we need to be able to talk with them to see where our model would fit. So it's like being a jack of all trades, master of none.
Yeah, like a lot of people talk about that T shape, right? Being able to go deep in one, but at least understand a lot and cover a broad subject area.
I think what you see, Artem, in the job descriptions is a sign of where currently organizations are about organizing their machine learning operations and MLOps mainly, and the answer is nowhere. So it means that a lot of companies still didn't wake up to the fact that productionized machine learning is a very serious engineering subject, and you need to treat it at the same level of where DevOps is. And I think going forward, what's going to happen is this is going to be absorbed by DevOps because every single company will do some kind of machine learning. Therefore, every DevOps team will need to have machine learning, aware DevOps teams, not doing machine learning themselves. And on the other hand, data scientists need to raise their skill level where they can interface with a DevOps team or an MLOps team part of a DevOps team. So it means that there is only going to be two types of people, and you kind of split the same way as probably DevOps and backend software engineering or front-end engineering. That's going to be the same, similar analogy, because currently, when you see these jobs, some of the job requirements are not at the level where a production level machine learning engineer should be, who can productively contribute to the bottom line. That's not, pandas or scikit-learn level. And a productionized machine learning system is reviewed code. You contribute in Git-like workflows. That's a different level where you would look for what you would expect from a job description.
Yeah, but I just usually call it engineering culture. So from my point of view, yes, DevOps guys will learn some ML and become take some job from us, but data scientists, they do really, really cool stuff, but they do. I would not call it like raise the how did you call it, raise the skills, but like implementing more culture. Like when they start liking Git, when they start acknowledging that Git is awesome, this will be the triggering the next level.
Oh man, you are a dreamer. So Artem is calling out, by 2025, data scientists are going to be appreciating how awesome Git is, huh? We'll put a date on it and say that they'll come back. The culture is going to change around it. I want to see it. I'm sure people in the comments, you can throw down how much money you want to bet on what side you are on. That's actually you just inspired me to make a new post.
Yeah, I must come in and say that I completely agree with the Artem. So it means that, or Artem, sorry, it's engineering culture, but that's for most of the data scientists who are usually come from either a non-engineering background, so a scientific background, academic background or business intelligence background, they need to adopt to this culture because productionized machine learning requires you to be able to collaborate with an engineering culture and be productive, because usually they talk in terms of you are not here to create models, you are here to create business value, but your job, a productionized machine learning engineer, job is to create machine learning models and put them in the product, and the ones which actually add value. You can only do that if you have engineering culture and engineering skills, and that's number one priority is loving Git.
Loving Git. You heard it here first. Data scientists are gonna love Git. I laugh now, but maybe you're all gonna be laughing at me for laughing, because I agree with you that it needs to happen. I just wonder how hard that is going to be, and if it's realistic that that cultural shift is going to happen. So we've taken a little bit of a detour, of course, from the engineering labs recap, but I really appreciate where this conversation has gone and all of the insights that you've given us on the process. I want to finish up with some final thoughts. I know we are a few minutes over already, so if you have to jump, go ahead and do it or let me know. But final thoughts on the whole process and anything from the engineering lab to the organization. I know Artem's got a few things to say about that. We've heard it already. He's giving me the look like, no, I'm done. I'm not going to talk about it. But the whole process, the final thoughts that you have. I mean, would you recommend it to people? Would you do it again? What do you got? And Paulo, can you start us off?
Yeah, I would do it again. I think I'm going to register for the next lab, unless I won't have time for that. I'll need to check depending on the topic and on the date. I think something that could be improved for the next lab would be to have some way of giving us cloud credits, so we didn't need to use our trial versions, or to have some common server on which we could all work on, so we don't need to find a way to work together from different places and with different machines. And that's
nice.
my biggest suggestion, besides the other thing that you mentioned of giving some more guidance in the beginning. But yeah, I highly recommend it.
That's right. AWS, GCP, Azure. If you're out there listening,
as a nonprofit, you can actually register. So the MLOps community is officially a nonprofit, right? You can register for some cloud credits, but they take like 30 days to answer you. But you can try.
We'll see if we can pull some strings, or if somebody out there listening can sponsor the video or the next engineering labs, and we can get some of those credits. All right, Dimi, final thoughts.
I really liked it. I'm looking forward for the next one. How Paul already mentioned, I think having a just kind of provider that gives us some credit to use all one platform is easier. Otherwise, you are very restricted in a way. But besides that, it was very nice to collaborate with everybody. I really appreciated that, different thoughts, different ways of solving problems. I think this is the cool thing about MLOps in general anyway, in the community. So yeah.
Excellent. Artem, what do you got to say about our organization? Here comes the real feedback. What do you got for us, man?
I have like the advice to us future and the future lab participants. Have a common call, have a common like beer session as fast as quick as possible. Get to know each other, and like this will make this much more fun. Yeah, and also I wanted to add, Demetrius, I listened the coffee session of the team one, and you said the thing that I was not expecting, that this labs initiative is going to grow to something like Kaggle for MLOps. And I think this is awesome. This will rock. So good luck to all of us for this.
We'll see if that vision can be realized, but that's what we want to do. And we also want to do so that everyone out there who's listening knows, if there is anyone listening after this hour and 15 minutes of us blabbing on. But the main thing that we want to do next, and we're trying to work with a few people in the community, Mark specifically, who was working at the UN, we want to have access to data, and we want to do things for good. We don't want to just do random pet projects anymore. I think it was an awesome start. The first one was incredible that we did this. We got to see where we lacked and how people responded to it. But what we want to do is find a way to take all of our expertise and use it for good, so that even when we finish the labs, the product stays around and it can be useful for maybe an NGO or potentially the UN. We'll see if we can go on that big of a scale, but that is the idea. And doing it in a Kaggle fashion is another grand vision that Ivan has. We'll see how that all plays out. We're going to have to be very patient because, as we all know right now, only 16 people signed up and 8 finished. So the next one, hopefully more will sign up. Everyone will tell their friends. I mean, that's part of the reason that we are having these sessions, so that people can know what to expect when they sign up. Last thing, maybe Laszlo, you can finish it off with some final thoughts on how much time you spent on this and how much, so that people can have a realistic expectation of what to expect when they are coming into the lab. Was this something that you dedicated an hour to a week, or was this a full-on side hustle, 20 hours a week? What were you doing?
Maybe the other guys are better positioned to answer this question. It was on my mind a lot, and especially after the final result was handed in, I spend a lot of time reading the code and understanding of how actually it works, because I'm not too familiar with Kubernetes. And it was very good for that purpose, that now I have I know what it's supposed to do, and I can read it. And now I know that this part is corresponding to that function or something like that. So even if I can't do it myself, I can follow someone else's work. And I think that's a very important, familiarization technique with usually in the community, because there's just so many things you want to learn about. As we progress with future labs, there are going to be more templates on what the next teams can use, so they don't need to start from zero. So I think they will going to have a bit of a kickstart or a lower threshold to get to some productionized system, and that's a very important feature in this events.
Yeah, you all are building the foundation. You're just laying the groundwork right now, and hopefully we can work off of that and stand on the shoulders of giants. So, folks, thank you so much for coming on here and giving us your feedback and telling us what you went through, how it was, what you did with MLFlow, what you did with the data sets, the process of choosing the actual problem that you want to solve, and then the process of being with 3 strangers and yourself, right? And having to work with them and how that was. So I love it. I really appreciate you all coming, sharing your time with me, and we will see everyone next time for more coffee sessions with no coffee.
Thank you.
Thank you, guys.
Thank you, guys. Thank you.
See ya.
Goodbye.
Thank you. Bye.